Anyway, hello everyone, I'm Pavel Odintsov. I am here from Fastnet1 project. Fastnet1 project focuses on DDoS mitigation and detection. And for more than 10 years, I work in network security area in different directions, but mostly I focus on exactly on this area. But my experience can be quite unusual because I'm work with IPv6 and cybersecurity mostly from perspective of software engineer. So in my talk will be cover more specific things from like implementation side instead of like operational experience. So all the time I'm very open about any kind of conversation, talks, ideas. All the time I'm very happy to talk about new stuff and in particular IPv6. So you can find ways how you can contact me. And actually you can see one site here, it's like GitHub. And I think, it's a good point to bring the attention, it's only one site which actually bothers me about lack of IPv6 support. Because, when I switch to IPv6 on the environment, like just to test how it works, it's like one of the main deal breakers. So folks from GitHub, please fix it. So let's move forward. My talk is okay. So my talk has a name like DDoS detection and IPv6. So because when people say like DDoS, so there are actually lots of meanings about what actually DDoS is. Because because we may have type of network attack, like which is typically well known, like when your like favorite site experiences outage, it can be explained like, okay, we experienced a DDoS attack. But unfortunately, DDoS term is very wide. So many things can be explained, like even software bugs, like buffer overflow used in special way. And I just want to start explaining what kind of DDoS I want to focus on. So, and of course, I will start from ancient stuff, very old stuff. So protocol version IPv4 level 3. So old, outdated, but it's very good to look and about types of DDoS attacks because when you read media, you may find out lots of exciting ways how people explain and name DDoS attacks. But when technical person reads something like application level attacks, protocol level attacks, but actually what kind of protocol do you mean? Like protocol can be HTTP, protocol can be BGP, protocol can be ARP. It's not clear what kind of attack we are talking about. And in this presentation, I would like to start from explicitly clarifying what kind of DDoS attacks we are talking here. So what is DDoS attack? What does it mean? Like this attack was implemented using level 4. So, and let's look on message format for IPv4. So we can see actually lots of fields here. Fortunately, IPv6 is not that complicated, but we have actually two types of fields here. So first type of fields is surveys. They are crucial to deliver packet from one point to another. And they cannot be changed. So because, for example, if you mess up with field version or IHL, or maybe destination or checksum, it will be dropped somewhere before it will reach your target, like your service, which just became target of DDoS. But everything else here can be changed because it actually how bad guys implement DDoS attacks. So they can use different terms of service field. Why not actually? They can change total length. They can use like 0 total length. In some cases, it may trigger very interesting circumstances. They can try actually use identification field, which is not recommended, but it may appear, when you intentionally want to create packets which can like break something. Or of course, lots of fun with don't fragment fields, more fragment fields, fragment offset. It can be randomized very well because we have 13 bits here. Like time to live, it's also a good point because why not? You can actually, by using like very small time to live, you can actually cause a router of destination and attacked part to like drop many packets. And again, it may cause some interesting effects. Protocol field, fine, can be changed, can be randomized, can be set to specific one. That's actually why I said like when people say like protocol like level attacks, which actually protocol type, many of them actually, you can even randomize them. And next thing, which is very important about delivering traffic from one thing to another. So, and actually it's like source address or destination address. And for IP protocol, it's not required to keep source address, not like as legitimate. And many networks, unfortunately, will allow using a fake source address. So it also can be randomized. And finally, destination address. You may actually randomize it because in some cases it may cause some interesting effect because, for example, in recent like months or actually I would say years, it started to be very common when attacks, it's not hitting specific like /32 or /100, but a range of them. Sometimes it's a very big range, and this effect itself can cause problems. And of course, when we move to payload, in payload we can do many interesting things. So you can see we may have lots of types of attacks which can be explained by just this diagram. What kind of like, so we may have literally any field in IPv4 header randomized, and then we will have like TTL flood, maybe protocol flood, and that's actually why I don't like this explanation, this classification about this. And that's why I like idea to focus on like using level of protocol we use in this case of attacks. And let's just compare IPv4 diagram with IPv6 one. So it looks much simpler. Does it mean that we cannot implement all fancy attack types mentioned for IPv4? Unfortunately, it doesn't. So again, we have next header, which is protocol. It can be randomized. Hop limit, again, can be randomized. Payload length, fine, can be any. We can like use it fake one, real one. Source address can be randomized. Again, unfortunately, destination address, it's different story. Actually, IPv6 creates a really great vector of DDoS attacks, which can use only the like destination address. Because when I said like for IPv4 attacks, it's quite common to see attacks against range, but range in IPv4 it's small. Even if your company is very rich or very big, you may have like even like /8, maybe typically /16. But in case of IPv6, you own, plenty of them. And then just attempt to send single packet to every single IPv6 can cause problem. So, and it actually means for every very different IPv6 for like message format, we have exactly the same attack vectors. Only one thing actually, which is very beneficial for IPv6, it's quite unlikely to see fragmentation attack types because of implementation of extension headers for IPv6 protocol. It's much more tricky to implement it. It may be dropped somewhere in the transit. So, and what we have here, and let's move, we perfectly described what we have for L3. So and then let's talk about ways how people typically explain those kinds of attack types. So it's protocol flood. Typically, it's not like random protocol. It's UDP, ICMP, TCP, GRE in some cases. And fragmentation attacks, when actually your network starts receiving lots of packets like more fragments or don't fragment or something different. Spoofing attack types, all kinds of attacks when you see source of packet, which is actually not real, because you may start seeing like lots of like malicious type from Google or Amazon. No, of course they cannot do it this way, but it means that somebody else in between you created fake one. So options flood, all kind of different tricks with IPv6 options or IPv4 options, TTL expiration attack, and terms of service flood. Last one is weird. I actually never saw it, but everything else, in some cases, I saw it in real. So it's, from my perspective, I think it's a good way to start from the beginning, like what kind of attack we are talking about. Because when people say like, I have an attack, because if you can explain your kind of attack very well, then people can help you much better. And I can say like what we can do or we cannot. And let's move from level 3 to level 4. What we have for TCP, for example, because I just don't want to talk about the UDP, because UDP is just, source port, destination port, that's literally all. But TCP is much more interesting. We have lots of fields. So every field here can be abused by attackers. Like checksum, in some cases, urgent, fine, window size, absolutely fine. So lots of different control flags, fine, they also can be used for attacking here. So, and then it means it's perfectly fine to use it for DDoS. But what is this actually special about this one? So, and actually nothing. What is special about IPv6 protocol about TCP? Of course, we can implement different attacks type in this case, but is it different from IPv4? What, like when you experience TCP, like flag attack over IPv6 or IPv4, is it different? No, actually, only one difference is source IP and destination IP from your perspective, because that's only one thing we care about. So that's why actually in my presentation, I will mostly talk about level 3, but briefly about level 4, because it's important and that's all what would like to talk about. So, and briefly from level 4, we may have source port attack, when just port randomized or port is set to 0, destination port also kind of often stuff, and TCP sequence and all kinds of misuse of TCP flags. So that's topic what we are talking about from DDoS perspective. So in this case, we are not going to talk about sophisticated attacks on maybe some endpoint exposed by like web servers. No. We are talking about L3, L4. That's all we want to talk. And next, let's talk about scope. So we are talking, and in this case, but when we mix actually L3 and L4, you may notice some more marketing attack names. And here you go, we have amplification, like spoofing, like Jerryfoot, but it's more like, it's more like product names of attack types. Because when people say amplification, because actually it's not important for you, was it amplified traffic or not? It just explains like how attack was started, but result for you, it's exactly the same. It's like megabits, hundreds of megabits, gigabits, hundreds of gigabits of malicious traffic coming on your network. In this case, it's not important. And for you, it's like UDP flood, which use fragmentation, like, and very big packets. That's all you need to know. So it's back to my previous slides about like how you can explain attack type, because instead of using like, and lots of people, they like buzzwords like slow lorries, like iron cannon, but it doesn't explain nature of things. But when you can explain, I receive packets with randomized source, fine, it's the best thing you ever can explain those attacks. And next thing what we are going to talk about is scope of IPv6. Like many people may say like IPv6 and attacks, does it make sense? No, is it even real? Because many people, they actually haven't tried IPv6, and many, unfortunately, ISPs, they don't offer IPv6. And like, it's actually first thing and first map you can find out and Google like penetration rate of IPv6. And I think it's most popular diagram for this kind of this presentation. And you can see it's from Google perspective. Actually, you can notice like clear correlation. That's very populated countries like maybe India here, like states. They have very good IPv6 enablement rate. So it's getting bigger. And when you're talking about DDoS is not artificial thing created by, shady genius somewhere in the middle of, Alps or whatever. It's just function, because it's not important where is the bad guy sitting in. They can sit in any countries. And media, they do love speculate about like, it's attackers from this country or it's not important for us. It's one of the things which is kind of fortunate. They will use our IoT devices, or like smart speaker phones, smart bulbs, smart, Christmas trees, whatever you may see in your environment, or your boxes somewhere for like security even actually, or for like smart home, and they will use them for attack vector. So you may find out clear correlation between like how many people in this country, how often they use some smart devices, and then you can experience them maybe not immediately, because when country got some good penetration of internet, you need to wait for some time before everyone buys like plenty of smart home devices for their home, and then wait, they will be used for as DDoS vector, unfortunately. So, and that's why it's very important to see like what's penetration rate for every, and you can see on this graph, it's very good. Like many very big countries are getting IPv6 serious, but this diagram is absolutely incorrect. And Veronica said absolutely right. This diagram missing is China. And one of the fascinating things about China, because many of us hear success story about Indian internet, like because it got IPv6 in very fast fashion. But for China, it's much more interesting. So let's look different like map for Akamai. You can see like sorry about color selection. It wasn't my choice. I'm very sorry. And so you can see that color of like India and China, it's close. It means we are about, what is in percentage? Let's look at that. This one also data from Akamai. And you know, they're on 16% of IPv6 now. But it's not important. 16% is not a big number. But check numbers year ago. It was about 0, maybe 2%, I don't know. And it's great dynamic. So if we can consider this kind of dynamic, we can expect maybe 15% in the next 2 years. So that's why actually it's clear it's growing. And China has enormous population, lots of people, every kind of people. They want like buy like some IoT devices, some equipment, whatever, lots of connected devices at home. And they, of course, will be used for DDoS attack. So, and from experience of FastNet project, I would say that most of our users who use actually IPv6 in their network, they experience at least one attack over IPv6 protocol per month. It's not often, but it's one of the things which can, you know, when it happens, it may be happening Christmas night, New Year, whatever, your favorites, you know, your birthday party, what else? It's one of the things which you need to keep you awake in, you know, in the night. And what we can do actually, and we have many challenges specific for DDoS. So it's a brief explanation. I will go into details for every specific like topic I mentioned here. It's like telemetry, how actually export information about IPv6 traffic, BGP for IPv6, black hole implementation, and traffic engineering. And actually, when we are talking about enabling and deploying any kind of solution for attack detection or network automation, first thing you need to deliver traffic from your equipment in some ways, because plenty of ways actually to deliver it. And one of the challenges here is like people who love old technologies. It's really a big problem because, you know, one of the most popular network telemetry protocols, it's NetFlow. And, you know, it has few versions, version 5, version 9, version 10, which is also known as IPv6. But problem is, you know, what is the point to use NetFlow version 5? And actually, one of the main things and main problems about protocol NetFlow version 5, it just has no field for IPv6 because it's so old protocol. And there are no reasons, actually, believe me, no reasons to use it. Because most of the modern network equipment support NetFlow 9 or IPv6, or actually even better, my favorite one, SFlow. So just don't use it. But unfortunately, if you can solve this kind of problem and your equipment supports IPv6 properly, and next thing, it may be you may experience quite rarely. You may find out way to send network telemetry to your collector over IPv6 protocol. So they can carry information about IPv6, but not, and many times they cannot send this information from switch or router to IPv6 only collector. So it's big problem, and you can actually yell on your vendor, like, please fix it. But none of the problems are here mentioned like very serious. No, if you already use NetFlow 9 or SFlow or IPv6, you already cover it. You have all stuff in place. And from perspective of FastNetMon, because FastNetMon is a tool which can notify you in case of like when specific host in your network experience like enormous spike of traffic. Like typically you experience like no more than 100 megabits for specific host, but then suddenly it is like 1 gigabit or 10 gigabits. And we need to like read information from telemetry about like what is the IP address for this host, what is the target, what is the source. And actually it's only a single change which was required to enable IPv6 support in FastNetMon telemetry engine. So it's literally single thing. Like if you received field in NetFlow 9 from the left side or IPv6 on the right side, which has like 16 bytes and specific number, because actually this like it's constant. IPv6 SRC address, it's part of standard. There's RFC about IPv6 or Cisco's implementation about NetFlow 9, and that's all. You have it in place. You can decode it. No fancy encoding, just like array of 16 bytes fine, simple. So even from, typically you don't deal and don't implement this stuff from your network manually in coding, but we did because, it's our purpose. And you can see it wasn't rocket science. It was literally just like, a few hours of work. And next thing, IPv6. Will you experience any kind of issues with IPv6 about BGP protocol? It actually depends on your position, because if you just operational like engineer, you just enable it and it works. But unfortunately, under the hood, it's quite tricky actually, because NLRI for IPv4 was implemented not very flexible way, because nobody imagines that something with like IPv6 will emerge. Nobody expected it. And that's actually why switch from IPv4 for BGP to IPv6 is quite for BGP it's quite painful if you are maintainer or developer of BGP daemon. In this case, you need to completely change encoding protocol, because different addresses, different way to encode stuff. And unfortunately, when we started implementation it in FastNetMon, so we stuck. So because in FastNetMon we use Go BGP daemon. If you haven't tried it, I would recommend. It's really nice. It's really simple. It's offers API, command line tool. It implemented a fancy programming language in Go. It's very secure, not extremely fast, but it's perfect for task of like when you need to inject some, prefix, read something from your routers, establish session, and it says support for plenty of very like unusual protocols like IPv6, MPLS, VPN, like many of them. And one of the actually roadblocks we experienced when we started work on adding IPv6 announcement for FastNetMon. So actually, when your IPv6 host attacked by like bad guys, we need to like notify you, of course, via script or what else, or email, and also we need to notify your routers to like stop sending traffic, like just keep our network alive. And actually, when we tried, and we finished the implementation for code, we started making this. And one of the things we experienced, it was like next hop is not supported, because actually it was a bug in Go BGP, and thanks to this guy from Cisco, he fixed it. And for our site, it was just upgrade to new version, and then here you go, it works. I think it's a great example how open source works, because when one open source project depends on different one, like, you can just ask people to implement it, but typically they had same problems, because I suppose Cisco hit exactly the same problem. Like they tried to make IPv6 announce, and unfortunately it failed, because just nobody tried to use IPv6 announces and Go BGP with IPv6 next hop. I don't know why actually. Maybe they used like IPv4 next hop. It's very unlikely, but maybe nobody tried. So, but it's good stuff. So we finished it, we implemented it. It's only one thing, we just changed this version of Go BGP, and so it works fine. No issues. And I would say from many vendors, no issues with BGP IPv6 implementation. Like not for this connection, I never heard about them. It's very old stuff. It just works most of the time. You may experience like issues with like new implementation of BGP, like Go BGP, but you can see it can be easily sorted. So again, no problem from BGP perspective. And also, so as this project was successful, we enabled option to notify your border routers or like different BGP speaking device about like you are under attack using custom community, next hops. And one of the things actually, it's very, very good, because for communities, nothing changes. Because we just used exactly the same logic as IPv4, because only one thing which changes between when you move from BGP IPv4 to IPv6, you just replace NLRI encoding, because in BGP packet it will be just empty, to MP-rich attribute, which is quite complex encoding, like with many fields, but it's not rocket science, and it's typically hidden from you by developers. What kind of problems we may have as next step? So let me guess. BGP black hole. Because when I started talking about black hole DDoS attack types, I did not mention that what kind of mitigation we have in this case. But unfortunately, in many cases and for many companies, they don't have enough capacity to absorb and scrub or filter out DDoS attack. They need to keep their network alive. And from this perspective, when we are talking about maybe residential ISP which use IPv4 only, or like small or medium-sized or large scale cloud provider, or even worse, like some cloud cloud surveys. One of the problems they have, because because of cost of IPv4, it's enormous. Really, it's expensive. And that's why people typically stuff single IPv4 address with many services. And actually, when you start talking with people like, okay, if your specific host receives the DDoS attack, you can just block it and then go forward. Fine, no problem. And then people are like, oh no, everything on this specific IPv4 address because it was so costly for us. Because it's $15 per IP address, but when you buy in bulk, but for small ranges, it's even more expensive. And when you rent it from your cloud provider or your residential ISP or for business, it's much more expensive. And in some places of planet, like example China, it's even more expensive. So you cannot afford buying lots of IPv4 addresses. That's why people allocate many services. But what we have for IPv6, like enormous address space. So typically you receive at least /64 from your ISP. And then what does it mean? So instead of using ports, I would say like this port for DNS service, this port for HTTP, this port for HTTPS service, and sharing many services, like HTTP service using virtual host on same like IP address, you can allocate actually single IPv6 address, or even worse. I mean it's better. Different subnets for different services. Like your company provides 100 different microservices or APIs. Fine, allocate different /64 or even bigger networks for them. And what is the benefits of this approach? It may sound like complex, like so many IP addresses. I need something to maintain them, because as I said, going crazy. Like where's the IP address for this service? But it's very beneficial because for IPv4, if you experience DDoS, you cannot move specific IP address to scribing center, or ask for well-known vendors on market to filter it out for you, because it's limitation of BGP protocol. You cannot move /32. You can move /24, but again, it's expensive and it's stuffed with services. You cannot move it easily. But for IPv6, I heard actually a great story from one of the users of Fastnet, because actually what they actually do is they allocate because they're a cloud provider, and they allocate /48 for every service and every customer which uses their service. What is the benefits of this approach? It maybe sounds like, oh, they're busting so much IP, so addresses, but it's extremely beneficial because it's not. They can of course use BGP black hole to isolate specific service of specific customer instead of blocking whole customer completely. And even actually better, they can reroute specific prefix into cloud scribing center in case of DDoS. I think it's really great stuff, not only just blocking it, because actually typically it's implemented first way, you need to block it because otherwise your network will experience downtime. And next thing you need to think about what is the better options. And then you can sign contract and ask for emergency help from cloud scribing sorters, plenty of them you can find. And then just move this specific IPv6 prefix to them. And here you go. Finally, this specific customer is covered. Instead of just black holing this one, you can, save them and provide great service and very precise service. But one of the things which is quite, as I mentioned, it's very flexible. You can easily move traffic around to different part of planet. You can move actually traffic to different data center which has more capacity, because typically if you work for a big company, you may operate big distributed network, like for example in somewhere maybe in London you have lots of capacity, but in this specific location, maybe somewhere in Indonesia, you don't have it. Then using IPv6 addressing, you can easily move all traffic away from this small location to big location and scrub it, filter it out, use all your available tricks for it. But one of the things which is quite unfortunate, because many ISPs, of course, they support black hole community for IPv6 protocol, but it implemented only 128 bases. So you can black hole specific address, but sometimes you will need to block /64 or maybe even bigger network. So it's a good point to clarify with your ISP what's boundaries, what you can afford blocking. And it depends on your addressing, because you need to understand, like, we can sacrifice this prefix, but we cannot sacrifice like /48. And so mostly for many cases, if your ISP provides IPv6 transport for you, it's perfectly fine. So typically they will provide black hole for you, and it's good news, no problem. Again, no roadblocks in this case. And as I explained in previous, because black hole in traffic engineering is quite related, because it's actually, I covered many things from this slide on previous slide. And because one of the things I would like to mention, like many people talking around like about any cast, like, it's very just when you know exactly the same service from many locations. But when people tell it, typically, oh, it's expensive, deadly expensive. No, you cannot afford it. If you're a small company, you cannot afford it. Fortunately, you can. So you can implement any cast over IPv6, because even basic allocation from RIPE can be /32. Then it means that you have plenty of /48, and then you can allocate many number of many different locations and be happy. Spread load this way, deliver traffic to like data center, which actually is backend for service, and handle it's much more flexible ways than IPv4, because for IPv4 we cannot move this /24 prefix because it's expensive. And we reach a point of most sophisticated and complicated challenge of IPv6, automation. So we have BGP session with our upstream. We can block traffic. IPv4, IPv6, fine. We have information about network telemetry, what actually happening in our network. But what we can do if it happens in the middle of the night? Okay, somebody will call us, PagerDuty, make us angry, ruin few days. We have different options. So main point of this presentation was like, I'm very happy to announce that in FastNetMon community, we added support for IPv6, complete one. Back in time, we had like small pieces of IPv6 support implemented in it. But current version, because actually it was so big change, and that's why actually we decided to split it in two versions. And you can, find out our GitHub page and install it. And current stable version is 1.19, and it includes every single change and every single like feature required for IPv6 mitigate attack detection. So you will, if you like download FastNetMon configured, it will actually implement very simple thing. It will read a stream of NetFlow or SFlow information from your routers. It will calculate what is the current bandwidth for your specific host in your network, not remote one. It's quite common misunderstanding. So it will maintain counter, like for this specific host in my network, we have 10 megabits. For this one, 5 gigabits. For this one, maybe nothing. And every second or more often, it compares value of like packet rate per second for this host, number of TCP packets per second, flows per second, actually so many different kinds of thresholds we support. And then when specific host exceeds this, it calls actions. So it can be a script call. It's not very important, but of course it's very crucial for implementation. It can pass information to PagerDuty, like via being attacked. And next thing, because FastNetMon was built with automation in mind. It wasn't built like tool which can help you to fight this. It was built as tool which can automate process to fighting DDoS. And then what we can do to automate it completely, because typically somebody wake up to you in the middle of the night, and then you try to find out your coffee machine. No, not coffee machine. You're trying to find out access to your routers to create actually these big hole announcements. And with FastNetMon, you can create this automatically. So when some host in your network, like maybe residential ISP with like 100 megabits plan, exceeds specific threshold, like maybe 1 gigabit, it will be blocked automatically by FastNetMon. It can do it for IPv6 too. And currently it works on boundaries on 128. But if you operate on boundaries or /64, it's perfectly fine. We will need just make small change or just raise issue at GitHub, and we will expose it as configuration, because I already hear that like some people can like unhappy about implementation of for 128 because they like a bigger chunks and bigger networks for specific customer. And then it will solve your problem mostly and cover main challenge of DDoS mitigation for IPv6 protocol. And so this one is just like how it looks from command line, because it's main way how you can monitor fastnet from command line. Of course, we have support for InfluxDB, Grafana, many different ways to export traffic information, but this one is main one because you can see all your, actually this one is my home connection from British Telecom, and I'm very happy to have IPv6 at my home because it helps a lot with testing, because sometimes it's just complicated to find out, like we need some real IPv6 traffic, how I can find out, enable IPv6 for your home. So, and then you can see like many hosts, bandwidth for them, flow rate, and actually it scales very well. And we have confirmed deployment of customers with 2 more terabits of capacity. So no limitation, no issues. And if you hit any issues, bugs, just reach us at GitHub. And so if you want to try FastNetMon, we support all major Linux distributions. I mean, Debian, all 9, Debian 10, Ubuntu, LTS, all of them actually, from 14, 16, 18, 20, 0.4, and we have support for CentOS 5, 6, 7, and 8. So if you're scary because, you know, many people like, because yeah, we're talking about security, and then you see like sudo like start some very weird script from the internet, if you're scared enough, actually just open this script and find out URL, because under the hood, it just creates, it detects your operation system and downloads binary package, which you can download manually without using our scripts, because it's just for convenience, not for, you know, we would like to ask you for like for running some very strange thing using super user permissions. And so if you have any questions, you can find out me at GitHub, Twitter, LinkedIn, and I will be happy to answer questions.